I'm not used to, when they told me I was going to be in the basement, I assumed it was going to be a room maybe of like 5 or 6 people. So yeah, this is amazing. Thank you so much for coming. There's some really great speakers on at this spot. And it means a lot that you chose mine. My name's Ed. If you're not expecting this talk and you were expecting something good, the talk we're talking about today is how to stop the Gradle Snatchers, a talk about how we can secure our builds from bad guys. I guess we'll kick off by, first of all, introducing myself and my little dog there as well. I've got to shoehorn him in somehow. As I said, my name's Ed. I am a lead developer at ASOS. ASOS is a fashion retailer. We do ship to France. Maybe some of you use them. I don't look like I work in fashion, but I technically do. I'm an Android GDE. I like to talk about mobile security a lot, so if you come and see my talks, I tend to be talking about very similar topics, usually mobile security. I'm available on all good social media and Twitter. Feel free to tweet me or message me. My handle is at the bottom of every slide, so do tag me in a photo. That would mean a lot. Thank you very much. This is actually my first time talking in Paris. It's not my first time coming to Paris, but my first time talking. It's my first Android Makers. I'm enjoying it. I know we're only a few hours in, but it's awesome so far. So I don't speak very good French, but merci beaucoup for coming. Thank you. So this talk is going to be talking about supply chains. Now, supply chains is a term that you've probably all heard of, but just in case you haven't, let's have a quick kind of reminder what a supply chain is. So the supply chain and a supply chain attack is actually the attack on the tooling that we use when we generate our builds. So it's not an attack on the build itself, it's an attack on the kind of systems or tooling that we use whilst we kind of generate builds. So the aim of a supply chain attack is to introduce vulnerabilities or malicious code without being detected by us, the developers. In this talk, we're going to go through a couple of examples of that. So we will look at some real-world examples and discuss those kind of so we can avoid this and make sure that this isn't happening to you. So to cover kind of what we're going to be looking at, we're going to look at a couple of examples that have happened in the real world. We'll look how to secure dependencies, which are obviously a big part of our kind of supply chain. How to do that, obviously, via Gradle. And then we're going to look into kind of securing Gradle itself. Just a hands up, who is using Gradle? Quite literally everyone. Wicked. And hands up if you like audience participation. 3 people, brilliant. I'll try to keep it to a minimum. Last plug before we move on. I apologise to any Italians in the room that are offended by this image. I can imagine there might be some. I do have some of these stickers. I made them specially for Android makers. If you ask me a question at the end, you can definitely get one. And if you catch me during the conference, I'm sure I can give you one as well. Let's now talk about the elephant in the room, which of course is Gradle. As we've just seen through the show of hands, every single person here is probably using it in one capacity or another. But before we dive into Gradle, let's kind of take a step back and think about kind of the history of how we got here. Audience participation again, I'm afraid. Obviously, there was a time before Gradle. Yes, there was a time before Gradle. I'm sure many of us remember it fondly. Before, it was what I'd call the Eclipse years. We didn't use Gradle, we used Ant and ADT. Hands up if you've been developing that long. Wow, okay, I wasn't expecting that many people. A lot of people. I think collectively we can all agree that was called the Dark Ages. We've all been there, right? Some of these errors on screen are ones I actually took myself. It was a pretty bleak time for kind of build tools, and thankfully kind of Gradle came in to save the day somewhat later down the line. So AGP, the first version of that, the alpha, came out back in 2012, which feels like it wasn't that long ago, but when you say it's 12 years ago, it's quite scary. So it's been around for a little while, but it did take them a little bit of time before they released AGP version 1. That was in late 2014. And kind of at the present day now, we've got all the way up to AGP version 8. So we're all using Gradle. It's a well-established system. We know, we use it every single day. But the first story that I'd like to talk about is something that happened back in 2018. And this is a story that is coined a confusing dependency. Now, I wasn't expecting you to have all been around this long, but if you have, you've probably heard this story before, but you can switch off for 5 minutes and enjoy it with me. This story involves somebody that you might have already seen this morning, Marton. Marton's obviously a well-known face in the Android community, previous Android DevRel, now at JetBrains. But this story is back in 2018 when, in his own words, this isn't me putting words in his mouth, he was a relatively inexperienced dev. Now, knowing Marton, I don't believe he's ever been inexperienced at anything, but apparently he was. And this story involved him creating a sample project. I don't remember the ins and outs of the sample project, but all you really need to know was that he was fetching a dependency from Jetpack. The sample app he was creating had no internet capabilities. It wasn't going to use the internet. It was only, something to play around with. And he needed to play around with something, a dependency. The dependency itself doesn't really matter in this case, but what does matter is when he ran his code the first time, he saw an interesting error. Now, normally I see this error because I've forgotten to add the internet permission. However, in this case, Marton had explicitly not entered the internet permission, which made the whole thing very confusing because the dependency itself shouldn't have been fetching the internet connection. So, Marton, as a diligent developer, went through and checked his Gradle file to see what could be possibly going on. Now, for those that understand how Gradle files work, obviously, when we call the repository block, that's kind of executed sequentially. So we will first try and find a dependency from the first level of the first repository in the list. So in this case, the dependency would try to be fetched in the Google repository, and that didn't exist. Next up, it checked JCenter, where it shouldn't exist. Oh, sorry, I skipped a bit. So it shouldn't have existed in JCenter, but for some reason, it did. And this is where our first character of this story comes along, Fake Wharton. This is, I spent way too long doing this image, and it's not very good. I apologize. But what had essentially happened was a malicious actor, who we will call, for the benefit of this story, Fake Wharton, had created a dependency with the same name as the one that Marton was expecting from Jetpack, and named it exactly the same. So what was happening was, under this fake user, which, as you'll notice, Jake Wharton has 2 A's in there, was masquerading as being the real Jake Wharton and hiding dependencies under a folder of a well-known library by Jake. So within this repo, he distributed a number of dependencies to shadow these libraries, including the one Marton was using. Which meant when it came to the implementation, what was actually being pulled instead of the expected dependency from Jetpack was the malicious one from JCenter. So, long story short, what can we learn from this? Well, I think the very first thing is we're all glad JCenter's gone. JCenter, is no more. But I think the main takeaway here is that we should trust nobody. We should definitely be far less trusting when it comes to our dependencies. Dependencies are essentially just third-party code we kind of put an import statement in and don't really think much more of. So how do we go forward? How do we actually secure our builds, especially when it comes to dependencies? Well, through Gradle, the way you would do that is through something called dependency verification. So with dependency verification, there's kind of two levels here and 2 different ways that we can kind of look at this. The first way is checking the integrity. So that is checking whether the files that we actually download are the ones that we expect. So has anyone tampered with the files, similar to kind of what we discussed in Marton's story. And then we have the second sort of level as well, which is a little bit more involved, but also important, is checking whether the origin is compromised, or also known as the provenance. To do that, that is all about checking, was this file published by the expected author? Was it published by Fake Wharton or Jake Wharton? So Gradle, very thankfully, offers a solution for both. It offers checksum verification and signature verification, and I will show you how to do that right now. So We'll start off with checksum verification. Just for background, in case you don't know what a checksum is, a checksum can be performed on any file and is essentially a hash of that file. If you make any modifications to the file at all, the hash will change, and therefore you'll know that the file A, if you've changed it into file B by modifying some code, would not be equivalent without having to look in the files directly. There's a number of different algorithms you may have heard of that can do this. MD5, SHA-1, SHA-256. A couple of these aren't great because they do have some vulnerabilities in themselves. So MD5, I think was, you shouldn't be really using that anymore. Same with SHA-1. I think Google proved that that could be collided. That's when the two SHAs can be made the same for the same file or different files. And that was broken more relatively recently, but it's pretty good to use SHA-256 for this process, and that's what we would use in Gradle in this case. If you ever want to create a checksum, it's very straightforward. You can just create a file and then run on the command line a tool such as SHA-sum, which would print out a nice hexadecimal string that would be able to kind of show you the checksum of that file. But if you obviously want to do this in Gradle, the first thing to do is to kind of get set up to pull all of the associated dependency SHAs from your dependencies. Now, to do that via the Gradle Wrapper, you would use this task. It's the Gradle Wrapper with a flag write verification metadata, followed by the algorithm SHA-256. The task that I've put there in the kind of the brackets is optional. Now, if you run this without the task at the end, this is going to pull all of the default dependencies from your project and is going to generate a file with all of the SHAs in. However, if you have a particular setup where you have maybe different dependencies depending on different tasks you run, the task can be added at the end. So, for example, if you have a specific task that only calls a certain dependency, that would be the right way to do it. So in this example, I've called it without the task, so it's pulling all the default dependencies. And what that does is it creates a new metadata file within my Gradle folder. It's called verification metadata XML. It is XML, unfortunately. I know we're in a compose world now, but we can't get away from XML in some instances, and this is one example. And what that file looks like is something like this. This is essentially our configuration. This is at the top of the file is our configuration. What are we verifying? As we discussed, you can verify kind of the dependency metadata and the signatures. In this case, because we're just doing the metadata so far, that feature is enabled, and the signatures is not, but we will shortly see how to do signatures as well. And you will find a whole load of components. And the components are your dependencies. These are the descriptions of your dependencies. And for each one of these, it's going to print out the expected SHA value. So you can manually edit this if you want. It's a bit of a hassle. But you should also be able to just run this command and it will pull all of the dependencies and add this for you. But how does this work, right? So what this is actually doing is going to Maven. Hopefully you've seen a Maven repository and you know what those look like. And within Maven repositories, not only do you have the jar files or the AAR files for particular dependencies, you also have their associated hashes in .SHA-256 files, .SHA-512 files, etc. So what Gradle is actually doing is it's actually, when it's resolving a dependency, it's going there and it's picking up the files and dumping them straight out into this XML file. So what happens when things go wrong? If, for example, the values have been changed in the file or they do not match what we would expect, you obviously want to be issued kind of some sort of warning or, well, more prudent, probably an error, telling you that that's happened. And that is exactly what happens. So in this example, as you can see, we get an error at kind of compile time telling us that the dependency that was pulled doesn't match that we were expecting in our metadata file. And this is really, really useful for kind of spotting ahead of time these sort of issues that like Martin faced, where we're resolving a dependency that we're not expecting. This is, unfortunately, I don't think this necessarily comes for free. Or I think it will stop compiling, but if you want more info on the actual error, then you do need to add a Gradle property to your Gradle properties file, and that is on the screen there. So make sure you do that as well. However, if kind of failing on the console wasn't enough for you, there is also an HTML output available. It's slightly more consumable. So if you have kind of things failing, this is a really great way of kind of visualizing why they're failing and how that's kind of working. So that was kind of the metadata aspect. The next one is kind of looking at signatures. How do we verify that the author of a particular project, a particular library is who they say they are? So what in most public Maven repos require signed artifacts. They're usually signed using the PGP standard, pretty good privacy standard. The developer, to sign something, must create a key pair, and then they must upload their public key to a key server. Now, off the top of my head, I think Maven Central requires one of 3 different key servers, one of which is the MIT key server. So, yeah, they have to also be sort of uploaded to trusted key servers. And once those artifacts are signed, they can then be uploaded to the Maven repo, which allows this kind of provenance check. So if we take a look at how we would set this up, so if we want to also verify metadata as well as signatures, we would do the previous command with the PGP at the end. It's very similar. Again, it can take an optional task if you need to expose more dependencies. And what that will do is, as expected, turn the previous Boolean on, meaning that we're now checking both metadata and signatures. And that will also add a new block of trusted keys to your verification metadata file. These keys are the hashes. They're not the actual artifact themselves. And again, how this works is the Maven repo has all of the files that we've just seen, the MD5, the SHA-1, the SHA-256, SHA-512, but it also has something called an ASC file. The ASC file is a PGP signature file that can be used to verify the identity of the artifact. And these are uploaded kind of at the time of uploading the artifact through kind of the Maven process. So in this example, I will try and verify Timber 5.01 against locally against kind of the key. In this case, I haven't got the public key installed, so I need to get Jake Wharton's public key, which can be found on his website. I've pulled that locally, and now I'm able to verify that the Timber AAR file that I have locally is valid. One thing to note, actually, here, it's a good point. I didn't spot this the first time I ran this, but this actually says that his key is expired, which isn't a problem. It's not a problem if the key is expired. It's only a problem if the key had expired at the time of signing the artifact, which in this case, it wasn't, so it's all good. So even though it says the key is expired, that's a valid output, and I would be quite happy knowing that that Timber file has come from Jake himself. So that was a very, very quick overview of kind of how to kind of verify dependencies. There are pros and cons, as everything has. There are pros and cons. The big pro here is that you gain trust in your application's dependencies, which I think is something we should all be striving for in our mobile apps. It's very important that if we're creating apps that are going to be in our users' hands, that we've done our due diligence and make sure that the apps are secure. The good thing about Gradle, as we can see, is that there is kind of a level of flexibility on how to verify the dependencies. You can kind of go all in with the signature check, or you can also just verify the metadata and make sure that the files haven't been modified in transit. Of course, one of the big pros is that you will also mitigate any supply chain attacks. So Martin's issue, where somebody had uploaded a malicious file, would have been thwarted straight away. That wouldn't have happened. And also, the big benefit is that you will sleep a lot better at night doing this, and so will I, because I know that you'll be doing it. So those are the pros. There are cons, and as you might have been able to ascertain, this is not frictionless. There are quite a few problems getting this started initially. You have to also start at a place where you already trust every single dependency. So if you run the commands that I showed earlier in the slides straight away, right now, what you will be doing is you will be pulling all of the dependencies from wherever they're coming from, and at that stage you haven't really verified, are they what I expect? So this is a very good process that you can start from day zero, but maybe if you're years down the line of building an app, something that's going to take a little bit of time to get to a place where you are kind of comfortable that everything is coming from where it should be. I've put one of the cons here that it's XML. I just don't like XML anymore. I don't think anybody does. And yeah, the actual simplest solution, and which kind of bypasses this whole talk, is just to not ship with any dependencies, which kind of sounds crazy, but the ethos here is that we shouldn't be importing dependencies for the sake of it. We should be very cautious about what we import, and only really import stuff if we need it. So I know if you work in fintech, banking, etc., that is kind of the guidance, when there's that kind of extra level of scrutiny. But definitely, yeah, we should always be thinking about, should I really be adding this or not? Another kind of thing you can do, which is slightly different, it doesn't verify the dependencies as such, but it does add sort of, I guess, a little bit more of a check on, where dependencies are coming from, is through Gradle's repository filter. So through Gradle, you can filter what packages can be fetched from certain Maven repos. You can create rules to include and exclude dependencies. And this works not only for dependencies, but also for plugins. Apparently, there is a security issue in this prior to Gradle 7. Hopefully, most of us have passed Gradle 7, but please do use this if you're using Gradle 7 and above. And what that might look like is something like this. So, for example, in Jetpack, if I wanted to only fetch certain packages, I could include a group. So if anything from, I'm fetching any dependency that is com.example, I would want to fetch it from Jetpack. And I might want to exclude, by regular expression, I might want to exclude anything that uses my domain, because you probably don't want to be importing my dependencies. So you can also exclude via that as well. So I highly recommend checking out the Gradle documentation on this. It's something that's quite easy to set up. And yeah, this also has kind of a number of pros, obviously gaining trust that your dependencies come from the right source. This would have also actually fixed Marton's issue if he had added a filter to make sure that his dependency was only coming from Jetpack. Like I said, that would eliminate the ordering issue. So dependencies are only fetched, from the repo where they should be fetched from. The rule sets are quite complex, so if you have complex needs, all of the tooling is there for you to do it. And the other benefit is that you don't actually leak the dependencies of your app. And what I mean by that is when you have a kind of unfiltered list of dependencies and you're kind of iterating through each Maven repo, what you're actually doing is pinging those repos with a request for a file. And if that file exists, it will return it to you, and if it doesn't know anything about it. In theory, you could create a malicious Maven repo where you basically collect the data of applications and what they're requesting. So this is slightly better because then you can kind of make sure that you're only requesting certain dependencies from certain places. So that was 2018. All of this is now, but that story was from 2018. Let's move on to 2022, which when I wrote this talk was a lot closer than it is now. But this is all about the wrapper, the Gradle Wrapper, and how that was exploited for the very first time, and kind of how that was observed in the wild. So a quick question. Where is a great place to see hacking in the wild? Where if you want to see a new exploit, especially in the JVM world, where do you want to be looking? And the answer, of course, is Minecraft. Everybody, if anyone's going to be hacking anything, it's usually kids hacking Minecraft. So this story is actually about Minecraft, which is, I like Minecraft. I don't know if anybody else plays it, but I like it because I'm a kid at heart. is relevant. I do promise that this is relevant to us because Minecraft is essentially a JVM project, and many of the tooling that's used kind of in the multi-platform, the kind of multi-person servers are, using Gradle in them. This story actually concerns MinecraftOnline.com, which is the oldest multiplayer Minecraft server. I'm told that they created the server 2 hours after online capability was added to Minecraft, and it's been around ever since. So it's been around for pretty much as long as it could have been. Random fact, 290,000 unique players, which yes, quite a lot. And it's, I've not been on this particular server, but yeah, as you can imagine, it's one of the biggest. So like I said, Minecraft servers use plugins, and plugins are JVM projects, and Gradle is the build system. So that's kind of where the tie-in is here. So let's jump into the story of what happened. In this case, some player was slightly naughty. I don't know the ins and outs of what they did, but they got banned. I think they were trying to distribute malware, which, yeah, fair enough. That will probably get you banned. What the user then did was create a fake identity over a period of months through social engineering, and eventually work themselves into the development team for the server. Once they ended up in the development team, as part of kind of routine maintenance, they did add a malicious commit. Now, the malicious commit was this. It was updating the Gradle Wrapper.jar file. Now, how many times in our pull requests have we seen this? I know I've seen it a bunch of times. What would you think? Would you think anything of this? I don't know, probably not. But what actually happened was that this user updated the Gradle Wrapper jar file with kind of their own tampered version, and the exploit was designed to run on the CI only. So what happened was, when Gradle was running, it secretly distributed a Gradle Wrapper jar, and the exploit allowed this user to gain kind of backdoor access to not only the server, but also the underlying system running it. The attacker was able to send commands in the form of JavaScript to the server for execution, and it could have been anything, kind of from mundane to getting better items to also kind of reading the file system. So a pretty serious exploit, and actually this was, I think, the first known public supply chain attack on the Gradle Wrapper. So what we'll talk about now is how we can kind of prevent that, because in reality this is a very real possibility that could happen to our apps as well. There is mechanisms, as we'll discuss, to verify the wrapper's integrity. There is also verification of the actual Gradle binary. So that is the distribution that we download every time through the wrapper. And as we'll see, that there are resources available for us to do that, such as hashes of the wrapper and distributions that are available on Gradle's website. So let's first of all talk about how we would verify the Gradle wrapper itself. Now, one way to do it is through a script I wrote. I must admit, not a great script writer, but in theory, you could use this on your own CI to verify that the Gradle wrapper for your Gradle version is the one that is expected. As you'll know, we have kind of multiple wrapper files, and in this case, I'm just checking that the Gradle wrapper jar file is the one that is expected. It works in a very similar process. It's all about checksum checking, and yeah, this is a very lightweight script that you can put on your CI. You can see a few people taking a photo, so I'll pause. You all got that? The slides are online anyway, so I wouldn't worry. And I also wouldn't worry because somebody's done it better, i.e. Gradle themselves. So if you use GitHub, there is a GitHub action to do this. It's, again, a very lightweight GitHub action. I highly recommend you use this if you are using GitHub. It is basically a click-and-play solution. Works very, very nicely. So please, yeah, I'll give you another sort of 10 seconds to grab the QR on that. And the benefit of doing this is that it is super straightforward to implement. You could probably actually do this before I finish the talk. Please don't, because that will be very distracting, but you could. It easily slips into most of your CI pipelines, and GitHub users pretty much get it for free. So yeah, the benefit of that is that by verifying the wrapper is that you don't end up in the same position that we saw in the previous example where the wrapper is modified without our knowing. The cons are that it is still fairly unlikely that this happens. For this to really be a vulnerability to you, it would need to happen to somebody that's already got access to your source code. So I don't know if you've got a malicious employee, if you're working in closed source. It's a lot bigger problem for more open source projects. So if you are an open source contributor, this might be something worth considering. I actually couldn't think of any other downsides, so if anyone else thinks of any, please do let me know. Next up, let's talk about distribution. So the distribution is the actual Gradle binary that's used. It's pulled from the Gradle via the Gradle Wrapper, and I'm sure we've seen the Gradle Wrapper properties file many, many times over the years and modified this numerous times. We can actually verify the integrity of this file, and that's through a property called distribution SHA-256 sum. So what this will do is Gradle will check when pulling the binary that the SHA-256 hash matches. It should be noted that if you've already kind of pulled that file before, you'll actually need to purge it from your local cache to make this work. But kind of setting this up is very, very straightforward. You can actually do this via the command line, via the wrapper command. So for example, in this case, I'm slightly out of date. Sorry, these slides are slightly out of date. So I would be probably pulling a slightly more recent version of Gradle than 7.5. But if you did want to pull Gradle 7.5, you would pull it via like this and add this Gradle distribution SHA-256 sum flag. The parameter here is the hash, which is available on Gradle's website, so you can always verify that you are using the correct hash. One thing to note in this case is that you have to remember to run this command twice. Why? Well, the first time when you are updating a version of Gradle, the first thing that it will do is update the distribution URL and update the SHA-256 sum hash. But then you also want to pull the latest wrapper files. If you only run this once, you will update the version and the two properties in your properties file, but you won't be pulling the latest wrapper files. So please make sure to remember to run this twice. And we can see this in action. So if we did ever modify if you did ever pull back a version that was invalid, you would end up with something like this, where, again, your build would fail at compile time, telling you, the checksums don't match. So this is a really good early warning system for if somebody has modified, the Gradle distribution that you are expecting. Again, the pros here are that it guarantees the integrity of your Gradle distribution. It's very simple to set up. It's just running a command twice. And the verification is very quick. It doesn't really impact your build times. It doesn't impact anything, really. It is lightning fast. So, again, there's no real reason to not add this to your project. The cons, I guess, are to remember to update via the wrapper command and flag. You can do it manually if you want. I guess once you've kind of added that property, you can go in the Gradle properties file and modify it yourself. But if you do modify it yourself, you want to make sure that you run the wrapper command afterwards, or twice if you're calling it via the wrapper command in the first instance, just to make sure that you pull those updated wrapper files. And again, I can't think of many other cons. So maybe there are, maybe they aren't. But yeah, this is something very straightforward that you can do to your project today. Another thing that we might want to verify is the actual Gradle Wrapper bash file or shell file. It's often overlooked. There is no actual official process for verifying this at the moment. I think the official word on this is that some people like to modify their Gradle Wrapper script files. I've never personally done that, but maybe some people in the room do. Which means that there is no kind of official process for this, and you would have to roll your own solution. One thing to note here, I guess, is that it's a lot more obvious if somebody is modifying that file because it will show up in PRs. So if you have a kind of a pull request process, make sure it's thorough and you kind of catch any kind of unwanted modification there ahead of time. Or, even better, please add a couple of thumbs up to this Gradle issue on GitHub, and hopefully, a solution will be made in the future. So we're kind of at the point where I'm wrapping up, you'll be pleased to know. In summary, Gradle supply chain attacks are incredibly rare, but they do occur. We've seen a couple of instances where they've occurred. So you should certainly consider dependency verification, even if it's just repository filtering. That is a better kind of, you'll be in a better position than you were possibly before. You can obviously do that to ensure the origin, you can verify your wrappers, and you can verify your distribution. But don't take it from me, there are much more experienced people with better talks out there. There is a great talk by Cedric from Gradle at DevOps 2019 that goes into this. Obviously, some things have changed, but for the most part, it's very, very relevant and, yeah, a lot better than this. So please do go watch that. Gradle has a whole security section on its documentation, well worth reading. I said speak to a nice human from Gradle at Android Makers. I don't know if there are any, but if there are, please go speak to them. If not, they're usually at other conferences, and I'm sure there's plenty of them online that would be quite happy to take any questions as well. However, if you were asleep or hungover or not absent or whatever for this talk, this talk is now available as a blog. So if there are things that you want to kind of catch up on, things that you didn't quite understand, hopefully the blog it goes into slightly more detail that you can kind of read at your leisure. In any case, if you want to access my content, it's all at spaghetti.dev/talks. I talk a lot about mobile security. This is just one aspect of things I talk about, but please do check out my website for more. And I think that's it. Merci. Thank you very much for having me. I think we do have some time for talks.